Hello, welcome to Block 5, Fractions, Decimals, and Percentage Equivalence, Lesson 1. I'll share my screen. In today's lesson, you're going to learn how to represent tenths and hundredths as diagrams. It is very important for you to be able to have a pictorial representation in your mind when we talk about tenths and hundredths. But before we start, I would like to ask you for a huge favor. Click on the like button for the videos, share the videos to those you believe can benefit, and I'm sure a lot of children around the world can benefit from these videos. Subscribe to the channel and click on the notification bell. By doing this favor, you'll help support our mission of educating a global population of children, regardless of whether they have the money or whether their parents have the finance to send them to school or not, provided they just have an internet access. Thank you. Before we start, I would like you to answer the retrieval practice questions. Pause the video and answer these questions in 3 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. In the first question, you were asked to fill in the missing headings in the place value chart. Of course, by now, you should remember how we use the place value charts and the different column headings for the place value chart. In the next one, you were asked to write the fraction of the bar model. We can see here that 3 bars, remember the bars are of equal width, so 3 bars are shaded, so the fraction is 3/10 because it's 3 out of 10 bars. Here you were asked to write how many hundredths are equivalent to 1/10. There are 10 hundredths in 1, so 10 hundredths are equivalent to 1/10. Let's learn. So our first example is this. How would you write this as a fraction? Well, I'm sure you said 1/100th. Okay. How would we write it as a decimal? That would be 0.01. So we've been able to represent this in different forms. What about this? How would you write this as a fraction and then a decimal? Have a think. Well, I'm sure you didn't easily spot that there were 10 squares shaded. So what we'll learn from this is it doesn't really matter the number of squares we shade, but we need to be more organized. So we know this is 10 hundredths because it is 10 out of 100 squares that are shaded. And this is the same thing as 1/10. This is by simplifying this fraction. Don't worry about what I mean by that if you don't know what I mean, because we're going to work on that. But simplifying the fraction is using a common number that we can use to divide the numerator and the denominator. What has he even talked about? Okay, don't worry about these names I'm using because we'll come across them in the future. So if we divide 10 by 10, we'll get 1. And if we divide 100 by 10, we'll get 10. So this is 1/10, and we know 1/10 is 0.1. So if we get more organized, this is what it should look like. And we could shade any 10 bars to represent 1/10. So we have 1 column shaded out of 10 columns. That's what it means. What about this one? Have you noticed that we have 2 columns shaded, which gives us 20 squares, and then 3? So this can be written as 23 out of 100, which is 23 hundredths. And this is the same thing as 0.23. What about this one? I'm sure you can see that 38 squares are shaded. So this is 38 hundredths, which is the same thing as 0.38. What about this one? I'm sure you see that there are 40 squares shaded, 40 rows. So this is 4/10. Okay, remember the way I explained how this simplifies to 4/10, which is the same thing as 0.4. Okay, you have done some learning. Let's see what you can do with this information. Write the fraction and the decimal shown on the following 100 squares. Pause the video and answer these questions. Assuming you've paused the video and you've answered these questions, here are the answers. Let's discuss them. That's 52 hundredths. Why? We have 52 squares shaded. You can see we have 5 rows, which is 50, and we have 2 small squares shaded as well. So that will be 0.52. Here we have 30 squares shaded. So that is 3/10, or is the same thing as 30 over 100, which is 0.3. That is 0.15. And that is 0.7. This might be a little bit challenging, but it isn't. Here we have a whole 100 squares shaded. That is equivalent to 1 whole. And here we have 29 squares shaded. So if we were to write this, we can write this as 129 squares divided by 100, or 1 whole with a fraction 29 hundredths. And that is the same thing as 1.29. It's now time for you to practice. Pause the video and answer question 1 in 2 minutes. Assuming you've paused the video and answered the questions, here are the answers. In question 1, you were asked to match the representation to the fraction. By now, you should know how to match them. Here are our answers. So that is 2/10. That is 7 hundredths. 70 hundredths, 70 out of 100 squares. And then that is 15 hundredths, 15 squares out of 100 squares. Pause the video and answer questions 2 and 3 in 4 minutes. Assuming you've paused the video and answered the questions, here are the answers. Let's discuss them. Question 2, you were asked to represent the fractions on the 100 squares. 3/10 means you need to shade 3 of the columns. It's the same thing as 30 hundredths. Discuss with a friend or somebody, your parents. Why are they the same? Well, remember at the start of our lesson, what did we say? We said 10 hundredths is the same thing as 1/10. So they are the same. 10 hundredths is the same thing as 3/10. Okay? So if we have 1/10, if we have 3/10, if we multiply that by 10, we'll get 30 hundredths. So they are the same. Here, question 3, you were asked, Huan uses 100 square to represent 60 hundredths. Tick the diagram that represents this. Of course, 60 hundredths is 60 out of 100. So you need to shade 60 squares or 6 columns because each column is 10 squares. Here it is represented as a row. And here it doesn't matter. There are still 6 columns. Each of the column comprising 10 squares. Okay, let's do some new learning. You've done some practice. It is important for you to know that we can represent fractions and decimals using different representations. We can represent them in this form as a fraction and as a decimal. We can represent them as squares, as a diagram, and we can represent them in a place value chart. So if we represent this, we'll have 3/10. We'll have 3/10 counters in the tens column. And if we represent them as a bar model, we'll shade 3 out of 10 squares. Sorry, 3 out of 10 bars. And if we represent them in a number line, of course, we can see the number line, they are equally divided into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 into 10 intervals. So each interval has to be 0.1 because 1 divided by the 10 is 0.1 and 0.3 should be in that location. Okay, now that you've learned something about representing decimals or having different representation of decimals, I would like you to answer this question. Well, we want to represent 0.43, so we're going to have 40 and 3 squares. 40 and 3 squares. Now here, we know that will be 43. If we were to put a number there. And then if we write it in the place value chart, we'll have 4 counters in the tens column and 3 counters in the hundredths column, which represents these 3. In the path-hole model, we know 0.43 is the number. We already have 0.03, so we're going to have 0.4 here. And of course, that should be 43 on here. You pause the video and answer questions 4 to 7. Pause the video and answer questions 4 and 5 in 4 minutes. Here, you were asked to shade the grid so that each representation shows the same number. And here are the answers. So this is 4/10. So you need to, 6/10. So you need to shade 10 columns, which is the same thing as 60 hundredths. And then if you shade the bars, you need to shade 6 bars out of 10 bars. Here you were asked to complete the sentence. You need to shade how many squares? So it was missing 23 squares on 100 square to represent 23 hundredths. And you need to shade 70 squares on 100 square to represent 7/10. Pause the video and answer question 6 in 2 minutes. Assuming you've paused the video and answered the questions, here are the answers. Let's discuss them. Here you were asked to complete the place value chart so that it is equivalent to the shaded 100 square. The shaded 100 square is showing that we have 1, 2, 3, 4, 5, And then 1, 2, 3, 4, 5, 6. So we're having 56 hundredths. So if we want to represent 56 hundredths, it means we're going to have 6 hundredths and 5 tenths. Because 56 hundredths, if we write it as a decimal, is 0.56. Okay. Let's move on. Pause the video and answer question 7 in 2 minutes. Here are the answers. So here you were asked, what is the range of the numbers of squares they have shaded? It is important to identify the largest from the smallest number. And you know the range is the largest number subtract the smallest number. Here, this represents 60 squares. That is obviously the smallest. And this represents 16 squares. So if we subtract the largest, if we subtract the smallest from the largest, we will have the range. So you may be wondering why it is 14 over 25. Well, if we shaded so if we have, let's discuss this. So if we have, this is 60. Yeah. So if we have 60 hundredths, and then we have the smallest being 4. So this is 56. If we divide by 2 in the first instance, we're going to have 28. So we're simplifying. If we divide by 2 again, we'll have 14 out of 25. Okay. Let's move on. Okay, sometimes you can have different representations, and then you may be asked to find the range of the representations. In this question, it will be important to make them all have the same representation. Or don't you think so? Because looking at it now, it may be challenging to find the range. We know the range is the smallest subtracted from the largest number. So if we put the representations, this is what we have. This will be 4 tenths and 6 hundredths. That is equivalent to shading 46 squares, so 46 hundredths. And then here we have, this is equivalent to 4 tenths. So that's equivalent to shading 40 squares. Now we can see which is the largest and which is the smallest. So that's the largest and that's the smallest. Well, if you think about it, largest from the smallest, we can simply take 3 columns from that, and then we'll be left with 16. And that's the one that is blinking there. Now, 16 hundredths is 0.16. So the range is 0.16. It's now time for you to practice the last set of questions for this lesson. Pause the video and answer question 8 in 3 minutes. Here are the answers. So here, Alex shades A hundredths on a 100 square. Rosie shades B hundredths on a 100 square. Rosie has shaded 40 more squares than Alex. Write possible values for A. So we can have various answers. Okay. And then here you're being asked, what is the maximum number of squares Alex could have shaded? The answer is 60. And this is a good exercise to discuss with your partner. Question 9. Pause the video and answer the questions in 2 minutes. Assuming you pause the video and answer the question, let's discuss it. Here you're being asked how many hundredths of the grid are not shaded. Well, if we have 3 tenths, which is the same thing as 30 hundredths, so 3 tenths is the same thing as 30 hundredths. 5 tenths is the same thing as 50 hundredths. So if we add them to 7 hundredths, we see that we have 87 hundredths. So that if they're asking us the number of grid, so how many hundredths of the grid are not shaded, it is what is left over to make it a whole, which is 100. So if we do 100 minus 87, that gives us 13. So 13 squares are not shaded. So that's why it is 13 hundredths. This brings us to the end of our lesson. So what you've learned in this lesson is by being able to represent uh, decimals as in the 100 squares grid, you can visualize decimals in different forms. You can represent them as bar model. You can represent it in the place value chart. You can represent it in the 100 squares grid. Until next time, take care and bye-bye.